in this problem, the region we have is a triangle. So the bases, the three vertices are 0, 0, 7, 0, and 0, 7. And furthermore, the cross sections perpendicular to the base and parallel to the y-axis, they are semicircles. So I'm going to make a slice. It has to be perpendicular to base and parallel to the y-axis. And then this is a semicircle. I'm going to just draw this. I know it's this. I'll use this as a representation of the cross section, one cross section. And first of all, without much trouble, we can find this equation, the equation of the line, which is y equals negative x plus 7 or 7 minus x. You can double check that. Now, the next thing that we need is to find the cross-sectional area. Okay, in this case, to find this cross-sectional area, which is the semicircle, we are going to do this. Pi times the radius square, and because it's semicircle, therefore we need to divide by 2. And this diameter is 7 minus x, right? When this is x, this diameter is 7 minus x. So therefore this a of x is supposed to be that. Therefore it's going to be 1/2 times pi times half of the diameter, 7 minus x squared. So therefore this is going to be, if you simplify, 1/2 pi, and this is 7 minus x squared divided by 4. So that's the cross-sectional area. Therefore, the volume of the solid will be from 0 to 7, and 1/2 times, there's a 4 here, so 1/8 pi times 7 minus x squared. So that's it. That's why at the end there's the 8 in the denominator.